Hello, my name is Wisdom. Welcome to DevOps with Wisdom. In today's video, we'll explore what cloud computing is, dive into its various service and deployment models, and discuss the key benefits and common uses. Let's start by defining what exactly we mean by cloud computing. Cloud computing is the on-demand delivery of computing services. Servers, storage, databases, networking, software over the internet. Instead of running applications or storing data on your personal computer, you access those resources from remote data centers managed by the cloud providers. In simpler terms, it is accessing computing resources over the internet. To help you better understand cloud computing, let's compare it to something more familiar, real estate. Think about the difference between owning a house and renting an apartment. When you own a house, everything is on you. You pay the mortgage, handle repairs, keep up with maintenance, mow the lawn, and call a plumber when something goes wrong. You are in full control, but that also means full responsibility. Now compare that to renting an apartment. You simply pay for the time you live there. The landlord takes care of the building's maintenance, handles repairs, provides utilities like water or heating. It's more hands-off, more flexible, and often more cost-effective if you don't want to deal with the hassle. Cloud computing works in much the same way. Instead of buying physical servers, you're renting computing resources from a cloud provider. You pay only for what you use, just like rent. This pay-as-you-go model means you are billed based on actual usage, whether it's computing power, storage, or bandwidth. You don't have to worry about maintenance. The cloud provider takes care of the behind-the-scenes tasks like hardware updates, security patching, and replacing faulty components, just like a landlord. And if your needs change, scaling is easy. With cloud computing, you can switch to a bigger plan or add more resources in minutes without buying new servers or waiting for a new hardware to arrive. Under the hood, cloud computing relies on three core elements. First, we have data centers and physical servers. These are the backbone of the cloud. Cloud providers build massive facilities called data centers filled with rows of servers. A data center is a physical facility that houses computer systems and critical components like networking and storage equipment. These services are powerful computers that store data and run applications for millions of users simultaneously. They are not all in one place either. They are distributed across the globe to improve speed, availability, and fault tolerance. Next comes virtualization technology. This is where things get really clever. So instead of giving one customer an entire physical server, providers use software called hypervisors to split the server into multiple virtual machines. Virtualization is a technology that allows multiple operating systems and applications to run on a single physical computer as if they were separate machines. It essentially creates virtual versions of computing resources like hardware, operating systems, and storage, which enables efficient use of resources and reduces infrastructure cost. Each virtual machine acts like an independent computer and is isolated, which means different customers can share the same hardware without interfering with one another. Finally, there's high-speed networking. All those data centers need to talk to the internet and to each other. That's made possible by high-capacity fiber optic cables that carry your data quickly and reliably. To prevent disruptions, cloud providers build in redundant network paths. If one route goes down, the system automatically shifts traffic to another, keeping your services smooth and on always. Now that you know what cloud computing is, let's explore why it's become the go-to choice for so many organizations around the world. There are several compelling reasons, and each one plays a major role in cloud adoption. First up is scalability. One of the biggest advantages of cloud computing is its ability to scale with your needs. Whether your app suddenly goes viral or you're handling fluctuating workloads, the cloud can automatically grow or shrink resources in real time without needing manual hardware upgrades. Another key benefit is cost efficiency. Instead of making huge upfront investments in hardware and infrastructure, cloud computing lets you switch to a pay-as-you-go model. You only pay for what you use. This turns capital expenses into manageable operating costs. Next is high availability and reliability. Cloud platforms are built with redundancy in mind. They use multiple data centers and built-in failover mechanisms to ensure your applications stay online, even if part of the system goes down. This keeps services resilient and accessible. Then there is global reach and low latency. With data centers all around the world, you can deploy your services closer to your users. That means less network lag, faster loading times, and better performance, no matter where your customers are located. And finally, we have security and compliance. Leading cloud providers invest heavily in securing their infrastructure, from physical security and data encryption to meeting strict compliance requirements. In many cases, their security measures exceed what most individual organizations could implement on their own. Now that we've broken down the foundational technology behind how the cloud works, let's shift our focus to how those resources are actually delivered to you. This is where cloud service models come into play, defining who manages what and how you interact with the cloud. Cloud services are structured into three main categories known as service models. Each model defines what you manage and what the cloud provider takes care of. Understanding the difference between them is key to choosing the right approach for your workload. Let's break them down. Let's begin with infrastructure as a service, or IaaS. IaaS is the foundation layer of cloud services. It offers raw computing resources like virtual machines, storage, and networking components that you can provision and manage as needed. This model gives you maximum flexibility and control over your IT environment. If you're comfortable managing servers, installing operating systems, or configuring firewalls, IaaS will feel very familiar. In this setup, you're responsible for everything from setting up the operating system and middleware to deploying applications and managing your data. You get the hardware and the core infrastructure from the cloud provider, but you are in charge of what runs on it. This model is ideal when you need full control, like for legacy apps, custom configurations, or if you're building your own tech stack from scratch. Common examples of IaaS include Amazon EC2, Google Compute Engine, and Microsoft Azure Virtual Machines. Next up is Platform as a Service, or PaaS. PaaS sits one level above IaaS and abstracts away the infrastructure. With PaaS, you don't need to worry about managing servers, operating systems, or runtime environments. The platform handles all of that so that you can focus on writing and deploying your code. You get a ready-to-use environment that includes the operating system, runtime libraries, development tools, and even auto-scaling features. Your main responsibilities are application logic, configuration, and data management. This model is perfect for developers who want to move fast without being slowed down by infrastructure setup or patching duties. It's commonly used for building web and mobile apps. Popular examples include Heroku, Google App Engine, and Azure App Service. Finally, we have software as a service, or SaaS, SaaS. This is the most hands-off model. SaaS delivers fully developed applications over the internet, and everything from servers to updates is managed by the cloud provider. You simply sign in and start using the software. You don't have to worry about how it's deployed, how it's maintained, or how it scales. You just focus on using the product to get work done. Your responsibilities typically involve user settings, data input, or any in-app configurations. SaaS is best suited for common business tools like email, customer relationship management, and file storage. Think of services like Gmail, Dropbox, Salesforce. These are all classic SaaS solutions. Now that we understand how cloud computing works, let's talk about where it lives. In other words, where is all the infrastructure actually deployed? Broadly speaking, there are three main ways to set up your cloud environments: public cloud, private cloud, and hybrid cloud. Each of these deployment models serve a different purpose depending on the specific needs of your business, especially around security, control, performance, and compliance. Let's begin with the most common one, public cloud. In a public cloud setup, the computing resources like servers and storage are owned and operated by a third-party provider such as Amazon Web Services, Microsoft Azure, Google Cloud. These services are delivered over the internet, and you, along with other customers, share the same infrastructure. While you don't have direct access to the physical hardware, you can use the services through a web browser or API. The provider is fully responsible for maintaining and managing the hardware, software, and networking behind the scenes. This model is widely used for hosting things like web-based email, online productivity tools, cloud storage, and testing or development environments. Some of the key advantages of public clouds include lower upfront costs, since you don't need to buy or maintain hardware or software. No maintenance responsibilities as your provider handles it all. Virtually unlimited scaling, allowing you to grow resources on demand. High reliability thanks to large networks of distributed servers designed to stay resilient. This makes public cloud a great option for startups, rapid prototyping, or applications with unpredictable traffic patterns. Next, let's look at private cloud. A private cloud is built exclusively for a single organization. It could be physically located on your company's own premises or hosted by a trusted third-party provider. But unlike public cloud, it operates on a private network and the underlying infrastructure is solely dedicated to your business. This setup offers enhanced control, and because the hardware and software aren't shared with others, you can tailor everything, networking, storage, compute, to meet specific internal policies or regulatory requirements. Private clouds are often preferred by government bodies, banks, healthcare providers, and large enterprises that demand higher degree of control, privacy, and customization. Here's why many choose private cloud. It offers greater flexibility for customizing resources to match internal needs. You get enhanced control since no other organization shares your cloud environment. It allows for better scalability compared to traditional on-premise infrastructure without sacrificing control. This model is ideal for businesses with strict compliance and data sovereignty obligations. Lastly, we have hybrid cloud, arguably the most versatile of the three. Hybrid cloud combines both private and public environments. It allows data and applications to move between the two as needed, giving you the flexibility of the public cloud with the control and security of the private one. This setup is especially useful when you need to keep sensitive or regulated data on-premise while still benefiting from the scalability and cost efficiency of public cloud services for other workloads. Key reasons organizations choose hybrid cloud include meeting regulatory or data sovereignty needs by keeping critical data in-house, flexible scaling where you can extend capacity into the cloud during peak usage times, cost efficiency as you continue leveraging your existing infrastructure while saving on public cloud usage for overflow workloads. In short, hybrid cloud is ideal for organizations that want to balance compliance, performance, and cost without locking themselves into one environment. So whether it's the convenience of public cloud, the control of private cloud, or the flexibility of hybrid cloud, each deployment model offers unique advantages depending on your organization's needs. Choosing the right one comes down to finding the best balance between security, control, cost, and scalability. Now that we've covered what cloud computing is and how it's deployed, let's talk about how people are actually using it. Across industries and use cases, cloud technology is powering some of the most essential and exciting tools in our digital lives. One of the most visible examples is streaming and content delivery. Think of services like Netflix and Spotify. These platforms rely on the cloud's massive storage and computing power to deliver high quality video and audio content to millions of users all over the world in real time. Without cloud infrastructure, delivering that scale of content would be nearly impossible. Another critical use case is backup and disaster recovery. Many organizations use the cloud to automatically back up their data. That means even if something goes wrong, a cyber attack, a server failure, or a natural disaster, your information is stored safely in the cloud and you can restore it quickly with minimal downtime. Collaboration and productivity tools also thrive in the cloud. Apps like Google Workspace and Microsoft 365 have transformed how we work together. Teams can now co-author documents, spreadsheets, and presentations in real time, no matter where in the world they are located. This level of seamless collaboration simply wouldn't be possible without cloud-based infrastructure. And then we have data analytics and machine learning. The cloud makes it easier than ever to spin up powerful analytic clusters or GPU accelerated instances on demand. Businesses can process huge amounts of data, build real-time dashboards, and train sophisticated machine learning models without having to invest in expensive hardware or wait weeks for provisioning. So the cloud is clearly powerful, but you might still be wondering what are some of the concerns people have before making the leap. Let's start with security and privacy. Cloud providers take responsibility for securing the physical infrastructure, the data centers, servers, and networks. But customers still need to secure their own data. That means using strong passwords, enabling encryption, setting appropriate access controls, and following good security hygiene. Then there is the issue of downtime and reliability. While no system can guarantee 100% uptime, major cloud providers offer robust service level agreements or SLAs that promise 99.9% or higher availability. And because their infrastructure is spread across multiple availability zones, if one part of the system fails, traffic can be rerouted quickly to keep services running smoothly. Finally, we need to talk about vendor lock-in. Once your applications are built using a specific cloud provider's tools or APIs, it can be difficult to switch to another provider later. To avoid this, many organizations adopt open standards, using containerized workloads like Docker or leverage multi-cloud tools that let them move applications across platforms easily. So while cloud computing opens the door to amazing innovation and scalability, it's important to be aware of your responsibilities and choose the tools that give you flexibility in the long run. Before we wrap up, let's take a quick look at where cloud computing is heading because the future is already taking shape. One major trend is edge computing. This involves placing smaller distributed data centers closer to end users, often right at the edge of the network. By doing this, companies can reduce latency and deliver faster services. Think real-time analytics for smart devices or instant responses in online gaming. Instead of sending data all the way to the central server, edge computing brings the processing power right to the neighborhood. Another important shift is the rise in serverless computing. This model takes the concept of platform as a service even further. With serverless, you don't have to worry about provisioning or managing any servers at all. You simply write code and upload it. The cloud provider takes care of everything else. Your function just runs when it's triggered, scales automatically, and you only pay for the compute time you use. And of course, we're seeing rapid growth in cloud-native AI and machine learning services. Rather than building complex models from scratch, developers can now tap into pre-trained machine learning APIs for tasks like image recognition, language translation, and predictive analytics. There are also fully managed services for training and deploying your own models, removing many of the barriers that used to make AI inaccessible to smaller teams. As you can see, cloud computing continues to evolve and shape the future of technology. It becomes the engine powering today's apps and tomorrow's innovation. Whether you're just starting out building your own project or looking to scale something big, cloud skills are a must-have in today's digital world. So why not take the leap? Dive into your first cloud project and share your experience in the comments. I'd love to hear what you build. And if you found this video helpful, give it a thumbs up and let me know your thoughts or questions in the comments below. Don't forget to subscribe to the channel for more clear and practical cloud tutorials like this one. Thanks for watching, and I'll see you in the next